Good morning, students. In the last class, we have discussed about acids and bases in detail. Now, we shall move on to the next important part of this lesson, which is salts. So, what actually the salts are, how these salts are going to be formed, and what are the different salts that you are going to study in detail in this chapter, and those salts we are using in our day-to-day life. These are the things you are going to be studied in this particular part. So, now what actually the salts are first? How these salts are actually formed. If you just recall when we have discussed about neutralization reaction, what is neutralization reaction? When an acid reacts with base, it forms salt and water. This is known as neutralization reaction. So in this through this neutralization reaction, the salts are going to be formed. So then we can define the salts as what now? Salts are nothing but ionic compounds. They are the ionic compounds, which means ionic compounds, when I say the word ionic compounds, which has both positive ions as well as negative ions. In any salt for that matter, we see the two important component, which is positive ion component and negative ion component. Now these positive ion and negative ion are held together by means of electrostatic force of attraction, and then it forms what we call salts. And when these salts get dissolved in water, these positive and negative ions will readily separated. Now coming to the classification of salts now. We know that salts are classified into different ways. One such parameter on which the salts are classified is pH. So based on the pH values, the salts are classified as acidic salts, basic salts and neutral salts. Now first we shall look into what is the meaning of this acidic salt. Acidic salts are those salts whose pH value is less than 7, and these salts are going to be formed by the combination of a strong acid with a weak base. When any strong acid combines with a weak base, it forms what we call acidic salts. The example we can give for this is ammonium chloride. Let us take an example of ammonium chloride now. In the ammonium chloride, NH4 is the part which forms the base and Cl is the part which forms acid. So base means, as I told, OH will be the group attached to the base and H is attached to the acid part. So for NH4, if you add OH, it becomes NH4OH. That becomes ammonium hydroxide. It is a base. For HCl, you are going to add H. That becomes HCl. It is an acid. So ammonium hydroxide is a base and HCl is the acid. When you combine these two, it forms what we call ammonium chloride, which is none other than acidic salt. In the same manner, if you look into another salt which is given here, that is ammonium sulfate. There also we can see NH4OH, again it is a base, and SO4 with H, it becomes H2SO4, it is sulfuric acid. So again it is a weak base and a strong acid results in ammonium sulfate. Next is the basic salt. Again, the basic salts are another category of the salt which are formed by the combination of a strong base with a weak acid and whose pH value is more than 7. Strong base and a weak acid always results in a salt called as the basic salt. The example we can give for this salt is sodium carbonate, that is Na2CO3. In this particular salt, again Na stands for base part and CO stands for acid part. And which acid is there here? That is carbonic acid, that is H2CO3, and base is NaOH. When you both combine these two parts, it forms sodium carbonate, which is a basic salt. So sodium hydroxide, once again, it is a strong base and carbonic acid is a weak acid. Now let's move to the next salt category is a neutral salt. As the name indicates, the neutral salts will have pH which is equal to 7. And here it is formed by the combination of a strong acid with a strong base. Any strong acid combined with any strong base, it always results in a neutral salt. So for example, NaCl, the best example is NaCl, which we use in our day-to-day life as a common salt. Sodium chloride. If you look into the sodium chloride, again here stands two important parts, which is strong and which is a strong acid and strong base. That is NaOH is a strong base and HCl is a strong acid. It results in NaCl. Similarly, Na2SO4, again NaOH is a strong base and H2SO4 is a strong acid. Both results in a neutral salt. So NaCl, KCl, Na2SO4, all these salts belong to the category of neutral salt. Next, we shall look into the very important part of the lesson is the preparation of certain salts and uses. Very important from the examination point of view. So here we are going to study certain salts, how it is going to be prepared, and how how the molecular formula is going to be right, and what are the uses of that particular salt. Let us move on to the first salt, which is known as sodium carbonate, which is normally referred as washing soda. And the formula written for the sodium carbonate is Na2CO3 10H2O. Now question arises in your mind. Normally, if you have studied these things in your lower classes, you just remember you have written for sodium carbonate as Na2CO3. We never use this 10H2O. Why it is 10H2O comes here? So we can write in both the way. We can write as O3H2O. Both are right. But why you have to write NH2O? Because this particular salt is what we called hydrated salt. They are called as hydrated salts. Salts which contain more water molecules are referred as hydrated salts. This is one salt which contains water molecules. That's why it is called as hydrated salt, and that's why we write the formula Na2CO3 10H2O. That's why it is referred as sodium carbonate decahydrate. Now, how this particular salt is being prepared? This salt is prepared by heating one more salt, which is known as sodium bicarbonate, which is commonly referred as baking soda. So when baking soda is heated strongly, it gives what we call sodium carbonate. But that particular salt what we get is an anhydrous state. What's the meaning of anhydrous state? Without water molecule. But when you cool this particular salt, then it forms, or then it absorbs the water from the atmosphere, and it forms sodium carbonate decahydrate. So you can see that equation here. That is NaHCO3 will forms first Na2CO3, which is the anhydrous state. When that is cooled, it forms Na2CO3 10H2O, which is sodium carbonate decahydrate. Now we shall move on to the next important salt is Now we shall move on to the uses of salt. What salt? That is sodium carbonate. Now you go to the uses of this particular salt. So sodium carbonate can be used in the preparation of glass, soap, paper, etc. Sodium carbonate can be used in laundry for washing clothes. Sodium carbonate can be used as a cleansing agent for domestic purpose. And sodium carbonate is used to remove the permanent hardness from the water. So we know that water is of two categories, hard water and soft water. That is because of the presence of calcium and magnesium. If the water contains calcium and magnesium, we call them as hard water. If the water is free from those salts, we call them as soft water. So wherever the hard water is there, those calcium and magnesium can be removed by using this particular salt called as a sodium carbonate salt. So that's why we use this salt to remove the hardness. Now, next important salt you are going to study here is sodium hydroxide, which is commonly known as caustic soda, and whose formula is NaOH. You know already that one. This particular salt is popularly known as alkali because it gets dissolved in water. Now this particular salt is prepared by a process called chloralkali process. Now in this word chloralkali, there are two important words. One is the chlor, another one is the alkali. Chlor is for chlorine and alkali is for NaOH. Why? Because this particular salt is actually prepared by passing what we call electric current through a concentrated solution of sodium chloride. That means we have to prepare the solution of sodium chloride, and for this we have to electrolysis that particular salt. When a sodium chloride undergo electrolysis, it gives this particular salt called as a sodium hydroxide, with the formation of hydrogen and chlorine gas is going to be liberated. So because of this chlorine gas which is going to be liberated in this particular preparation, that's why it is called as chlorine or chlor, what we can say. Chlorine is the gas, and because of that it's called as chlor, and because of NaOH it is known as alkali. That's why the process name is known as what we call chloralkali process. So NaOH salt is prepared by a process called chloralkali, where the sodium chloride salt solution is going to be electrolyzed. Then you get sodium hydroxide and also the liberation of the hydrogen and chlorine in the respective electrodes, that is in positive and negative electrodes. Hydrogen will be liberated at the positive electrode and chlorine is liberated at the negative electrodes. Next we shall move on to the uses of sodium hydroxide. As we know, sodium hydroxide is also one of the most important salt used in the manufacture of soaps, detergents, paper, etc. They are also used as a laboratory reagent. They are also used as a cleansing agent for machines and metal sheets. They can also be used in the refining of petroleum. They can be used in cotton industry for making the unshrinkable cotton fabric. Next, another important salt that you are going to study here is sodium hydrogen carbonate, which is normally referred as baking soda or also called as sodium bicarbonate, whose formula is NaHCO3. Now this particular salt is how it is prepared. Let's see now. Baking soda is prepared by passing the carbon dioxide gas to the solution of a brine again. Again you have to pass the solution or pass the gas to the solution of sodium chloride. So with the addition of ammonia, we have to add a little amount of ammonia to the solution of sodium chloride, and then you pass the carbon dioxide gas to it, then we get a salt known as the baking soda. Now look into the equation here. So NaCl plus NH3 plus CO2 plus H2O give rise to NaHCO3 plus NH4Cl. Later onwards, this NH4Cl is being filtered by a process called filtration. So we get back the salt called as sodium bicarbonate. Now, what are the uses of this baking soda? Very important applications are: number one, it is used in the preparation of baking powder along with tartaric acid. So baking powder, you're already familiar with that, which is used to prepare the bakery items. Then used as antacid, very important word in the same chapter we have discussed in the beginning, that is antacid. This salt is also used as antacid. Then again it is also used in fire extinguishers. Now very important thing we have to identify here is baking soda is used as antacid. Why it is used as antacid? Because it is going to neutralize the acidity which is produced in our body. When acidities happen, at that time you have to take the tablets which contains this bases like baking soda. Similarly, why it is used in fire extinguisher? Because when you heat the baking soda, as I already given in the equation, you have to observe here is the gas which is going to be liberated is carbon dioxide. So because of the liberation of carbon dioxide, when you heat this particular salt, the carbon dioxide gas is going to be liberated, and that gas is going to eliminate the fire, and that's why it is used in fire extinguishers. Now another important property is baking powder is used in bakeries. Why? Let's see now. So baking powder is what actually? It's a mixture of baking soda and the tartaric acid. Tartaric acid is present in tamarind. Now when you mix these two components, you get a powder known as the baking powder. So when baking soda is added to a dough, it is used for making cakes or bread. So whenever you prepare a cake or a bread, for that particular dough what you are going to prepare, for that you are going to add the baking soda. Even to prepare the pakoda or bhaji in our house, we use this baking soda. Now when this baking soda is heated, we know it is going to release what we call the carbon dioxide gas, and because of the liberation of this carbon dioxide gas, it's going to make the cake fluffy. That's why when you buy the cake, we say that the cake is very soft and fluffy. The nature is because of the liberation of carbon dioxide. So when the carbon dioxide gas is liberated, that makes the cake to be fluffy and soft. And what's the use of this tartaric acid here? Tartaric acid is going to, suppose if you don't add the tartaric acid here, then that becomes bitter taste. So in order to maintain the taste, we have to use what we call the tartaric acid. So these two applications are very much important. So baking soda is because of the liberation of carbon dioxide. When you heat that particular salt, it gives the cake fluffiness. When you add tartaric acid, it neutralizes and thereby it reduces the bitter taste. The next very important salt you are going to study here is calcium oxychloride, which is commonly referred as bleaching powder, and whose formula is CaOCl2. This is another important salt which is yellow in color. It is prepared by passing again chlorine gas to a slaked lime. You know what is slaked lime? That is CaOH twice, calcium hydroxide. When you pass the chlorine gas to the slaked lime, we get one more important salt which is yellow in color, that is calcium oxychloride, which is known as bleaching powder. So we know that this bleaching powder is used for the sterilization of the drinking water, that is used in the purification of water. It is used in the manufacture of chloroform. It is also used as an oxidizing agent in the laboratory. Next, the very important salt you are going to study here is calcium sulfate hemihydrate, which is commonly referred as plaster of Paris. This formula is CaSO4, that is calcium sulfate 1/2H2O, which can be written as which can be read as calcium sulfate hemihydrate is the name of this particular salt. How it is prepared? This particular salt is prepared by heating one more important salt, which is known as gypsum, commonly known as calcium sulfate. Now, this gypsum is normally used in the manufacture of cement. So why this gypsum is added in cement? Because to harden, to make it hard. Cement will become hard because of the addition of gypsum. So that's why by using that particular gypsum, we can prepare one more salt, which is known as the POP. And this gypsum salt has to be heated to a temperature of around 373 Kelvin. So we get a salt known as the plaster of Paris. So equation is like this: calcium sulfate is going to be heat at a temperature of 373 Kelvin, is going to give another salt, calcium sulfate hemihydrate. But one thing we have to see here is calcium sulfate 2H2O, what I have written in the formula is, that is hydrated calcium sulfate. Again, this is one more salt which is an example for a hydrated, and apart from sodium carbonate, we have one more salt here which is an example for a hydrated, which is known as calcium sulfate or hydrated calcium sulfate, which can be written as CaSO4 2H2O. So when this salt is heated, we get a calcium sulfate hemihydrate. But one thing you have to remember in this equation is half H2O, as water of crystallization is taking place here, we cannot able to write as half H2O. Half H2O will never be existing in the nature. So therefore we have to write the formula as CaSO4 H2O. That we have to write the formula like that. So we should not write anywhere, fractions will not become anywhere, because fractions molecules will not be existing in the nature. So always we have to make it as a whole number when you write the equation. Now coming to the uses of plaster of Paris. So plaster of Paris, as we know, it is used for making the molds or cast, for making toys, pottery, ceramics, etc. In all these things we use this POP. POP is also used for covering the walls and the roofs wherever the leakage has happened. The very important application of the POP is in the medicinal part, that is in using surgery. Bones get fractured, they use this POP bandages, as you are already aware of that. And one more important application of POP is that it is used for making fireproofing materials, because this particular salt will have that ability to hold that particular material and will not make the material to catch the fire. So students, in this session we have discussed brief about the salts, its preparation and uses. With this we complete the second chapter in the chemistry. Thank you, and we shall meet in the next session.